Good morning.
Test, test,
Test, test.
testing.
Testing. Not testing. Hello. I guess you can hear me? Cool. Good morning, and thanks for joining us in 5 ways to improve your build productivity. My name is Boris, and I'm an Android Developer Relations Engineer at Google.
Hey everyone, my name is Miłosz, Relations Engineer as well.
In this talk, we would like to share with you top build productivity struggles and the solutions, how to sort them out. Come in, come in. So we start by updating tools and dependencies. We follow with dependency definitions that are all over the place. We will talk about how to configure your build config, how to scale our code base, and what happens when our build files are getting large and complex. And the first item is, please update your tools and dependencies often. So the more often we update our dependencies, the less update work we need to do each time. Updating early gives us more time for changes, so we can plan your features and updates in advance. And of course, here is a cherry. New releases come with the new useful features that can improve your build performance that we will talk shortly. Now let's discuss how to do it. Let's start from updating tools. Each time you see this nice Upgrade Assistant window, you know there is a new version of Android Gradle Plugin, which is called AGP. The Upgrade Assistant not only shows you that there is a new version available, but also it helps you with the migration of various DSL, which is build domain-specific language features. But of course, we will go over all the steps because it's for us, Android developers, to own and to understand every step in the process. So yeah, how to update the AGP? Pretty easy. In our build.gradle KTS, we upgrade to the latest version in the version directive. Once updating the AGP, we might need to upgrade the Gradle as well. If there is a mapping between the Android Gradle version plugin and the underlying Gradle version. And this is how you upgrade your Gradle. Please note that it's not enough to update your Gradle version only in the Gradle settings file, because you might end up with having unupdated Gradle wrapper. So it's better to do it in a proper way from the command line, where we both update our Gradle and our Gradle wrapper. Cool. After updating Gradle and AGP, there is a time to update our DSL. For instance, in AGP version 7, we removed the compile block and changed it to implementation. How many of you are using AGP version or the version which is less than the version 7? Oh, good. It means you all have been updated toolset. Another example is we are deprecating AAPT options block and replacing it by the Android resources. Speaking of AGP versioning, AGP stands for semantic versioning, which means major, minor, and page. And this is what these 3 numbers stand for. So what's important for us is the major version, which is 7. We update it once a year. It might include incubating APIs, so use it with caution. And it has all the deprecations and deletions. Now, as we've done with the tools, it's time to update our dependencies, which is essentially third-party libraries that provide functionality to our app. How to update dependencies? Also pretty easy. We go to build.gradle KTS under implementation block, and we update to the relevant version. Important to note is please avoid dynamic versions. Dynamic versions are stars and pluses inside the version declaration which is a regular expression. Dynamic versions create a really problematic builds, because you might build your app with one version, your friend might build the app with another version, and guess what? The app behaves differently. And these problems are really hard to track. As a side effect, dynamic versions causes non-optimal builds, as Gradle needs to do more network fetching to upgrade to the versions that fit to the regex. Another item is please use implementation unless you have to use API in the dependencies. And why is that? When Gradle sees the implementation directive, it doesn't publish the artifacts to all modules, which means less work during build, which means in turn faster build times. And this is something we all want. And of course, last but not least, please fix the deprecated API calls. You know, they start with warnings, then they could cause a slower build and runtime. And in the end, if you don't fix it, on one shiny day, your app will not be built. Cool. Now we updated our tools and dependencies, and this is the time to perform a full test cycle over our app. And yeah, as we discussed, one of the key advantages of using the latest tools, we get the cool new features that improve our build. One of them that we want to share about is configuration cache. How many of you are using or have heard about configuration cache? Excellent. So what is a configuration cache? It's a Gradle feature that reuses internal data between builds, which means possibly improve the build times. And of course, to get the optimal results, use latest possible AGP and Gradle versions. How to enable it? Pretty easy. In our Gradle properties, we set up this flag to be true. Or if you want to enable it from command line, we just call it. So to sum up, please update early, please update often, and use our AGP releases page for all information on the new AGP releases, DSL changes, API changes, Gradle conformance, and else. And with that in mind, let's talk about another cool feature, which is version catalog to manage dependencies. Yeah, we all have been here, right? We have a huge build.gradle file with a lot of dependencies, with a lot of dependency versions, and we are not happy when we need to update a dependency, right? Oh, I'm glad that the audience agrees. So yeah, what is a version catalog? Oh, how many of us have been using version catalog? Great, at least 20% of the audience. So this is for the remaining 80%. Essentially, version catalog is a one file with all dependency version definitions across the whole project, which is used everywhere in the project, which means a source of truth. Meaning, when we need to update dependency, we update it in one place. So here how it looks like. We will see the code in a second. We get this nice file, libs.versions.toml, that sits in a Gradle folder from our project. It got the versions the declaration on the top. Then it got plugins, libraries, and bundles blocks that are using versions. And then all our build.gradle KTS files are referring to exactly the same file for all dependencies, which means we have only one place to manage dependencies. Here how the file looks like, which is essentially going by the structure. We got the versions block, we got the libraries block, we got the bundles, which is really cool, where you can declare a few dependencies and import them using only one line. We got the plugins in the end. That's it. And of course, what is left? How we use it in our module build.gradle? Exactly as we used before. We got the implementation block. So either we add the library that we declared before, or we add a bundle. One line. Take a look how our build.gradle files are free from dependency declarations. or basically from dependency version declarations. Cool. To sum up, we really recommend to use version catalogs. Android Studio support for version catalogs will be added in the future releases. So sometimes when you fix something, you might see errors on your IDE, which means the IDE is not synced. The solution is pretty easy. You just rebuild the project and then resync all the files, and then you will not see the errors. And please check now in Android for a complete flow of the version catalog. With that, I'm moving to my colleague Milosz.
Thanks, Boris. Yeah. Give it up for Boris.
No, Milosz, it's because of you.
All right, but the talk is not done yet.
We just started.
To build an application, typical Gradle build performs a number of steps. However, chances are that some of those steps are unnecessary and can be skipped, sometimes conditionally and sometimes altogether. In this section, we'll cover some of the practices that will help your Gradle build avoid doing work that is unnecessary. In particular, we're going to talk about minimizing the repository count, creating flavors specifically for development, disabling the jetifier, avoiding generating build configs, and avoiding mixing Java and Kotlin. So, firstly, when Gradle attempts to resolve a dependency, it searches for a list of repositories in the order that they are declared. This means that you should limit the number of repositories to the minimum viable amount for your build to work. It also means that you should put the repository hosting the largest amount of your dependencies first, so that in the majority of cases, it ends up as the only repository being searched. This next tip will help you avoid compiling and processing resources that you aren't testing, such as additional language files or screen density resources. In order to do that, create a flavor specifically for development, and using the REST configs method, specify only the types of resources you want the build to include, and filter everything else out. Next up is a little bit of Android history. Back in the days, the support libraries were used to backport certain features to different API levels. In 2018, support libraries were deprecated and replaced with the new libraries from the Android X namespace. However, even if you exclusively use Android X in your codebase, chances are that some of your third-party dependencies still rely on the legacy support libraries. And the two namespaces are not really compatible with each other. So to help mitigate this problem, the jetifier was created. It's a tool that changes the bytecode of your third-party dependencies and replaces the Android support with the Android X. This process can take a substantial amount of your build time, and it's best that you disable it if you can. To be able to disable the jetifier, you need to make sure that your code nor any of its dependencies are using support libraries. In order to do that, you can use the Android Studio build analyzer. It has a built-in jetifier check that scans all your modules in search of the support libraries references and lists them for you. Once you're certain that your code is free of any support libraries, you can disable the jetifier in your Gradle properties. All right, this next tip is about a build config file, which might be familiar to you. It's a file containing static information about builds, such as application ID, flavor, debug flag, and others. Build config is generated by default. If you develop a multi-module application, you can end up with a lot of build configs, since each Android module can generate one. While sometimes useful, chances are that you won't be needing it at all. It can easily be disabled with a single flag in your build features section. One more thing that is worth mentioning is that build config is a Java file, which, assuming you use Kotlin, further improves your performance. Which brings me to our next point. Don't mix the two of them together. Consider some syntax constructions that are only available in one of the languages. Take Kotlin extension functions, for example. In Java, this kind of code is accessible as a static method. In order for the languages to be interoperable, the compiler needs to generate additional code, and that means more work to do. If you cannot avoid using both Java and Kotlin in your project, consider isolating them by putting them in separate modules. And speaking of modules, they might help you with much more than that. As the project grows in size, complexity, and number of contributors, it gets increasingly difficult to manage, build, and scale. The ever-growing and constantly evolving code-base problem. One way to address this challenge is a software technique called modular programming, or modularization for short. It's a way of organizing a code base into smaller entities, in our case, Gradle projects or modules. Important notice on naming: what we Android developers call a module, Gradle calls a project. So a multi-module build becomes a multi-project build in Gradle's terminology. In terms of build, there are at least 3 Gradle features that can leverage modularity to improve your build performance, and that's incremental build, build cache, and the parallel build. Perhaps you've seen something like that. Did you? I do. The up-to-date notice next to the task name means that its execution was skipped. This is a result of the incremental build feature, and it's Gradle's way of avoiding work that has already been done. Typical Gradle task takes some inputs, performs work, and generates output. With the incremental build feature enabled, Gradle checks inputs and outputs of a task to determine whether it needs to run again or not. For instance, compilation task takes a source file as an input and generates a class file as an output. If the source file didn't change and the output file has not been removed, there is no point in rerunning the task. Beyond incremental build, Gradle can save time by reusing the outputs from previous executions and providing it to the task that needs it. If an output of a task is used as an input of another task, Gradle can retrieve the output from cache and provide it to the task that needs it. In a multi-module application, we can take advantage of this to minimize the amount of Gradle tasks that need to run. Consider the dependency graph of the sample multi-module application. Suppose we introduce change to one of the modules. Input of this module, a source file, has changed, and so the module gets rebuilt. Since this module is used by another module as a dependency, that module gets rebuilt as well. And the change propagates to parent modules. However, thanks to Gradle's incremental build and build cache, none of the modules not affected by this change needed to be rebuilt. We can take this up a notch with the parallel build functionality. With a default configuration, Gradle can only run a single task at a time. With the parallel build feature enabled, Gradle can run multiple tasks at the same time as long as they are in different modules. In a multi-module application, we can leverage this to build modules simultaneously. You can enable the parallel build functionality by specifying a flag in your Gradle properties or using the command line argument. So the question remains, how should we modularize our application to leverage Gradle's functionality? Due to the flexible nature of Gradle, there are very little constraints in organizing your code base. The kind of modules and the relations will largely be dependent on your software architecture. concrete modularization strategy is out of scope for this presentation. However, these two universal rules will help you maximize the benefits that modularization has to offer. And those are keep coupling low and keep your modules lean. Low coupling means that modules should be as independent as possible from one another, so that changes introduced to one of the modules have zero or minimal impact on other modules. As we've seen in the example, changes propagate through dependencies. You should strive to have as little dependencies as possible. Another important thing to remember is to keep your modules lean. Most commonly used types of modules in Android development are the Android app module, which is the entry point to your application. It contains source code, manifests, resources, assets. The output of such a module is an AAB or an APK. The Android library modules are used by other Android modules as a dependency. They have the same content as the app module. So source code, resources, assets, manifest. The output of such module is an Android archive. Java and Kotlin modules, on the other hand, do not contain any Android-specific files and are built to a jar file. Since Android modules come with an overhead, preferably you'd want to use the Java Kotlin kind as much as possible. Although modularization offers a great deal of benefits, it comes at a price. As the number of modules increases, so does the amount of configuration files. It becomes increasingly difficult to keep your configuration consistent. Imagine specifying a dependency version manually for each of your modules. Or imagine changing a min SDK version on a code base with 100+ modules. Not only it's error-prone, it also leads to redundancy. Fortunately, my colleague Boris knows a way of dealing with large and complex build files. Boris, back to you.
Thanks, Milosz.
Thanks.
Thanks, Milosz. Can you hear me back? Can you hear me? Excellent. Yeah, we are here. We updated our tools and dependencies. We using version catalogs and configuration cache. We configured our build config. We modularized our code base into modules, but still something feels wrong. You know, we have a lot of build Gradle files, and all of them are full of tasks, semi-baked plugins, a lot of copy-paste code that we copy-paste between build.gradles. And of course, once we update in one place, we forget to update in another place. Yeah, I see you by your head nodding. This is the reality. Let's see how can we do better. Rule. Custom tasks and plugin implementations should not live in the build script. Point. So let's see what can be done. How many of us are familiar with build source? Nice. So yeah, build source, which is essentially a Gradle reserved name for a directory. It's included implicitly in every build. And it's a nice place to put tasks, plugins, or other classes used by our build. This is how it looks like. Relatively easy. We got the build scripts from all our modules that are referencing the stuff inside the build source folder. How many of you are familiar with that? More hands? Yes, that's a challenge with build source. As every change in build source triggers a full rebuild, 99% of it is not necessary, which means we are ending up with longer build times. So let's use another solution, which is called a composite build, which is essentially a Gradle solution to overcome the challenges of the build source. How many of us are familiar with composite builds? Very good. Now all the rest of the audience can learn. So what is a composite build? It's a build that includes other build projects. So instead of referencing a folder, we are referencing a project, And when we reference a project, Gradle can do a lot of things behind the scenes to make sure that not every change rebuilds everything. Here how it looks like, actually pretty similar to build source. We got our build scripts from all our modules, and we got the included build project, which is a whole Gradle project with build.gradle and etc. And this is how we connect it to our build by include build directive. So inside our root settings.gradle KTS, if our project is called my project, I'm always happy for better names, then we include build, which is in bold, for the build logic. And what's a build logic? It's a name for the Gradle project that we are using only for our build. Important to note, we are also have been using build source. I mean in Google Gradle Recipes project. And what we are doing now is we are planning to migrate from build source to use composite builds. Now let's talk about what we do or what we put inside our composite build. And this is also both Google and the Gradle recommendation is to use convention plugins. So what are convention plugins all about? A convention plugin is a Gradle plugin, but it abstracts application-specific need. And this is versus the usual Gradle plugins that we all know and like, such as Kotlin, Java, or application that abstract domain. And the convention plugins are applied by our build files, like any other plugin. And of course, when all modules use the same convention plugin, and we update the convention plugin, as all the modules apply the updated version of plugin. Or in software engineering, change once, apply everywhere. And of course, we are not limited to only one convention plugin, as we can have more than one. Here how it looks like. So we got the convention plugin, and we got all the build Gradle files that are applying this plugin. And a little bit more realistic code structure, or project structure. It's convenient to have a convention plugin that abstracts all the plugin logic that we need for a library. So for instance, 3 modules here are applying a special library convention plugin, while the 2 modules apply the compose convention plugin that abstracts all the relevant compose build configurations that we need. Let's see how to get started. Here are the steps. Basically, we need to create a build logic folder in our project root with settings.gradle file inside. We are not limited to build logic name, but this is an idiomatic name that comes with the Gradle best practices. Inside the build logic, we create a convention folder with build Gradle KTS and the source folders. Inside the source folder, we create Java and the Kotlin classes to implement our plugins. I wait a second if you want to take a picture of the steps. Once we have the skeleton, this is the time to implement our plugin. Implementing a convention plugin is like implementing any other Gradle plugin, which is essentially implement the APIs. Once we already implemented our plugin, we need to register it. How we register it? Relatively in the following step. In our build.logic convention build.gradle KTS file, in the Gradle plugin block, we register our plugin, which is a mapping between the plugin name and the implementation class. And the implementation class we have from the previous slide. Yoo-hoo. Now, after registering our plugin, we need to let our app know where to find the plugin. So inside the settings Gradle KTS, which sits in the root of our project, in the plugin management block, we do the include build logic. And again, here is the name of the folder that we used by, let's say, idiomatic convention. And what is left is to use the plugin. So inside app build.gradle KTS, we apply the plugin. So yeah, this is our goal. Please take a moment. This is how our build.gradle files should look like. They should have only 2 big blocks. One is for plugins, and one is for dependencies. We want our build files be simple. And here are the steps. Think what can you abstract and move either to convention plugin or to the classes or the tasks that are dependent on it. So you have, in the end of the day, a really clean build file. Thus, all the people who are working on the project, you have an easier life. And then you can do a strong separation of concerns, meaning what's important to build versus what's important to us as Android developers. As obviously, as Android developers, the thing that we should be caring the most are dependencies. Cool. To sum up, we definitely recommend to use composite build with convention plugins. Yes, it is engineering effort and maintenance. You have seen the steps. However, doing it once and properly, it's a better time investment versus having a whole bloat of build files with everything and trying to upgrade. And of course, please check now on Android for the full convention plugin implementation. With that, as we are going towards the finish of our meeting today, here are the additional resources if you are interested. So we got the Optimize Your PH and Gradle tools and tricks from the Android developer site. Also, Gradle user manual is really useful. With that in mind, we hope you enjoyed learning about the practices as we did while sharing them. You can happily find us at the Google booth, where we shall be more than happy to address any of your questions